This is section 823. We're going to take a look at the unit circle. So we're going to utilize the unit circle to evaluate common trigonometric values. So let's take a look at this scenario and what we're going to do. If we talked about, rotating on our coordinate plane, and we can create our reference triangle. So if I had the point, 3, 4, and we have our rotation, and so therefore, the x length is 3, the y length is 4, and my radius is 5. Why would we make the radius 1? Well, let's see what happens when we make the radius 1. So to make this 1, I'm going to divide everything by 5, which we're technically allowed to do because it's all a ratio of each other. Now, what ends up happening here is we get 1, 3/5, and 4/5. Well, let's take a look at, we said that the sine of theta is y over r. We said the cosine of theta is x over r. Well, when your radius is 1, we have this direct relationship that your cosine value is x and your sine value is y. Well, this is huge. That means that my sine theta and my cosine theta, those are actually part of the coordinates. So now I could say cosine theta is 3/5 and sine theta is going to be 4/5. So this is what we use to create the unit circle. So we examine this rotation, we make sure that our radius is 1, and then what ends up happening is the x coordinate of that point is the cosine value, and the y value of that point is our sine value. So let's kind of do some rotation here. Let's think about it. So if I know that I'm using the unit circle and my rotation is 270 degrees, well, that means my radius, right, is 1. So my coordinates are 0, -1. Well, if my cosine value is the x and my sine value is the y, I can say that the sine of 270 degrees is -1 and the cosine of 270 degrees is 0. Now, what if I wanted to look for a pattern? What if there's more to this unit circle than just that kind of simple isolated example? So what we're actually going to use are these special triangles. Remember the 45, 45, 90 triangle and the 30, 60, 90 triangle? Remember it's t, t, t root 2? Well, what ended up happening is we made the radius 1. Now, when you make the radius 1, this is what the different values are going to be. So, just to think about it this way, right, this would be 1, root 3, and 2. So if I divide everything by 2, you get 1, 1/2, and root 3 over 2. Now, what's going to happen here, and this is going to be a lot of information kind of thrown, what we're actually doing is taking all of these, and I mean all of these triangles, and putting them on the unit circle. For example, if I were to put the 45 triangle right here, well, that's 45 degrees. My coordinate would be radical 2 over 2. Now, if I put my 45 degree reference triangle there, the rotation is actually 135 degrees because all of this is 180. 180 minus 45 is going to be that 35 degrees left. Well, now my coordinates, this is negative root 2 over 2, positive root 2 over 2. Now I can take that and I can move it here. So then my rotation is going to be 180 plus 45, which is 225. And then I can move it here. That's going to be 360 minus 45, and that gives me 315. We can do that with the 30 degree reference angle. So 30 degrees. Same idea. We go through this. You can pause it and slow it down if you want, but we take all of these values and we put it on the unit circle. And then I could rotate that triangle and have the 60 degree reference triangle. And I could take that and I could put that on the unit circle and have everything rotated and go around it. 180 plus 60 is 240. And we just do that, and then 360 minus 60, it's going to be 300. And so we get all of our coordinates. And then obviously we have the poles, the x and the y axes, right? Remember the radius is 1, so we're moving one space this way. So that would be 1, 0. One space up is 0, 1. One space to the left is negative 1, 0, and one space down is 0, negative 1. Now, if we take all of that information and put it together, this is what it looks like. Yes, it's a lot. And then if I wanted to include radians with it, and so this is a little messy, and so we kind of organize it in this particular chart here, right, where the angles are on the inside and then the values are on the outside. Now, there is a pattern to this. We do have to memorize it, but there is a pattern to this, and we're going to go through that pattern. But for now, the only thing we need to know is how to use this to find the values. So remember, cosine is x, the sine value is y. So this is telling me the x value. This is telling me how much I rotate. So I'm going to rotate to 135 degrees. The cosine value is the x value, so what's the x value here? Negative radical 2 over 2. Sine means the y value. This is how much you're rotating. So I'm going to rotate to 270 degrees. My y value is negative 1. This means my x value. This is how much I rotate. So I'm going to look for the x value at 7 pi 6. So I'm going to rotate to 7 pi 6. My x value is negative radical 3 over 2. My x value at 5 pi thirds, so I'm going to rotate to 5 pi thirds. My x value is going to be 1/2. Now 360 is how all the rotation, so my x value when I rotate 360, so I'm going to rotate all 360, so my x value is 1. Now sometimes we have an angle bigger than what's on the unit circle. That's okay. All we need to do is either find the coterminal angle or you just keep going. So this is 360 plus 90. So find the y value by doing that. So 360 plus another 90. So my y value is going to be 1. And then remember negative rotation. So rotate negative 30 degrees. And so my y value at negative 30 degrees is going to be negative 1/2. So what did we learn today? In conclusion, we talked about the unit circle. And just to remind you, the cosine value relates to the x coordinate, and the sine value relates to the y coordinate. This does conclude our lesson. If you have any other questions, please leave them in the comments.